what we're really trying to do is our goals, our objectives are, number one, to help educate the next generation of geoscientists, of energy explorers. Then beyond that, we also need to develop the next set of techniques that tell us much more about the structure, the kinds of rocks, and the types of fluids in the subsurface. We have indeed found many of the easy resources. So going into deeper water, harder rocks, mountainous areas is very difficult. So we need the most advanced techniques. Well, we're very excited about putting sensors such as these deep in the ocean, actually in the ocean floor bottom, and we're investigating, exploring what exactly can we find with these when they're in the primordial depths, the profound depths of the ocean. Can we make better pictures beneath the salt below the ocean floor? Can we make better, more accurate pictures? So we're very excited about this technology. Also putting sensors such as this in boreholes and permanently monitoring producing reservoirs. So once we've found and we're recovering the resource, we need to know what's happening in the reservoir itself. We're really excited about the developments in energy research and education at the University of Houston. The city is uniquely positioned to have an enormous impact in the technologies and the recovery of energy resources. So in several years, we hope that this is in the top handful in the world in terms of the education, the impact of the research that we're doing, the technologies we're developing, and the science that we're producing.
I feel like the University of Houston geophysics and geology professors in the classes have really prepared me for my future career goals, mostly because it's given me a broad range of skill sets in both geology and geophysics. And with my current project, I've also delved into areas like reservoir modeling and things like environmental policies and political policies that have really helped me to be prepared for the workforce when I finish.
At the University of Houston, we've been able to put together a really pretty amazing team. Rob Stewart, John Castagna. We also have research professors here that have won all the major awards in the societies that are important in this field. So we've got this wonderful team together, and the primary emphasis has historically been on oil and gas, petroleum seismology, and related technologies. And that emphasis is still here because this is Houston, it's the energy capital of the world, it's a natural connection, and it's a very strong one. But there's also the application of the very same tools to environmental concerns. And this for years has happened in the shallow subsurface. Things like remediating brine spills and oil spills and using geophysical tools to image the limits of the pollution plumes and all that. But the new twist on it is with climate change, with CO2 becoming a primary issue in the last few years, is that our skills now are really vital to the characterization of sites that will eventually hold massive quantities of CO2. So the basic idea is that up here on the surface we might have a coal-fired power plant and all those facilities. From the stack would be the CO2 would be captured, compressed, and then put down a well. And as it goes down into the well, it would pass through various formations and then be injected in a place which hopefully is not at all faulted. And that's part of our job, is to characterize where these faults exist.
The university decided that they wanted to make an investment in having some scientists at the university doing air quality research, and so they hired a famous scientist from EPA and NOAA to come to UH. The EPA requires the state to tell the EPA how they're going to clean up the air. And so they just submitted October 7th the new state implementation plan, the SIP for Houston. The state of Texas submitted that to the EPA, and now it's going through a several month review process. But that plan includes a lot of our research and a lot of our data. So they looked at and saw, we showed them some of these new ways ozone's being made and gave them some new ideas on how they can improve the air quality, reduce these ozone levels in Houston. We're one of the few universities in the country, in the world, that has their own aircraft and has these long-term monitoring of all these different chemicals. And I'm sure we're one of the only universities that's got continuous formaldehyde, nitrous acid, NO2, ozone, CO. When I get a call from a graduate student that they want to come here and I find out they want to be a meteorologist, I tell them that they should go to A&M because A&M has this enormous meteorology program. But if they're interested in air quality, I say you can't beat the University of Houston. We're not trying to compete with other universities, but we have a specialty here that is hard to match at other universities.